All right, in this video, we're going to go over example 5. I wanted to give a quick mention of this link I put on your notes, which I think is pretty good. It talks about a concept called the fundamental theorem of algebra, and that's getting at what we're talking about today. It's basically a polynomial of degree n has n roots, and it gets into all the details about the degree, the roots, how it looks on a graph, and it gets into the complex roots toward the end there. So that's a good little read if you need some kind of further exploration on it. But I won't get all into what that is because we don't need every single thing from there in our lesson today. And so let's do number 5 here. I want you to pause the video, see if you can get all the roots, and try doing it in the synthetic division to get the roots, and unpause it, and we'll go through it a little quicker than example 4. All right, I have this top part filled out here. When you graph it, you should get it crossing at -3 and +1. I want you to recognize that a -3 is a double root because it's got a maximum there. 1 is a single root. So you should have a degree of 5 roots total, 2 distinct real roots from the graph, but one of them is a double root. So that counts as 3. This -3 counts twice. So since that counts twice, then there are 2 complex roots left over to get to your 5. So let's go ahead and get those. Pause the video, see if you can try setting it up in synthetic division, and I'll get it started. All right, well, I got the first synthetic division set up. Let's go through that. So you're going to take your coefficients, take one of your roots. Doesn't matter which one you start with, but I'm going to start with the -3 here. Bring down that 1, multiply, add down, and then multiply again. -3 times -2 is 6. Add down, you're going to get 2. And 2 times -3 is -6. Add down, you're going to get 44 minus 6 is 38. And 38 times 3 that's going to be 114. That's a -3, so it's going to be -114. And then you're going to add 75. Oops, let's see, -114. Then we're going to use Desmos. The calculator on the computer isn't as user-friendly, so anyway, that's -39. And then -39 times 3 is times -3. 117. And of course, we want that to be 117. We want that to be a root. So those are going to cancel out and give you 0. Now we're going to repeat it again. We're going to have to do this 2 more times. So you're going to do the -3 again because it's a double root, right? So anytime you have a double root, you're going to have to count it twice. You're going to have to use synthetic division one more time. So again, I'm going to write the 1, -2, 2, 38, -39. And I'm going to do it again. Let's separate those out here. All right, bring down the 1. 1 times -3 is -3. Add down, you're going to get -5. -5 times -3 is 15. Those add to 17. 17 times -3, I think it's 51. So -51. All right, 38 plus -51 should be -13. -13 times -3 is 39. And we did this right because those give you 0. So the goal is to get a remainder of 0, right? And we have one more root to work with. We've used this one here. So now we got to use this 1. I'm gonna go ahead and write that here. We're gonna use these 4 numbers, and I'm gonna cheat and not rewrite them. I'm just gonna bring that 1 down. Do it again. 1 times 1 is 1. -5 plus 1 is -4. -4 times 1 is -4. 17 and -4 is 13. And 13 times 1 is 13. And we did this right because our remainder is 0. So now we have a quadratic. It's going to be 1x squared minus 4x plus 13. So we're going to throw that into the quadratic formula. So the quadratic formula is x equals the opposite of b. Well, b is going to be -4, so opposite of -4, plus or minus the square root. B, so -4 squared, minus 4a and c, all divided by 2a. So 2 times 1. And let's work that out. So I want to get the stuff under the square root sign first. That's usually the hardest thing to deal with. And I'm getting -36. So that's going to be +4 plus or minus square root of -36 all over 2. Now you can square root 36, right? If you actually typed in this, if you're in a plus bi mode, if you typed in the square root of -36, it's going to give you 6i, right? So instead of saying I squared root of 36, we're going to just say x equals 4 plus or minus 6i over 2. And both of those are divisible by 2. So that's going to end up being 2 plus or minus 3i. So these are your complex roots. Together with your real roots, the double root at -3 and 1, that gives you 5 total roots. All right, the next video we'll go over example 6.